Hey, so I want to show you how to graph a quadratic function, and they can be pretty fun. They can be wild and crazy too, because you're always dealing with some kind of x squared, and so the function values can get get pretty large pretty quickly. I'm going to show you kind of a mostly harmless little quadratic function, x squared plus 3, and just a reminder that quadratic functions have this form: ax squared plus bx plus c, where a is the quadratic coefficient. So in this case, I kind of have an invisible 1 there. You know, 1 times x squared is x squared. So I could write this function as 1x squared plus 3. So my quadratic coefficient, or a, is 1. My linear coefficient is 0. I don't have one. I could have written this 1x squared plus 0x plus 3. Um, so that linear coefficient is 0, so it's just gone. And I did that to make it easier for us here. And the constant coefficient is 3. So this is a real live quadratic function. And to graph it, the first thing to do is to make a table, um, where you just choose some x values, write them down, and then plug them into the function and see what you get, and you just record the result of what you get over here. And then I'll show you how to take that and graph that. So first thing, just pick some values. Um, 0 is always a nice and easy one to do. I recommend doing that. And then I'm going to pick 1, 2, 3, and then -1, -2, and -3. When you're graphing linear equations in lines, all you really needed was 2 points, because you can just draw a straight line connecting the points, and then that was your line. With quadratic functions, in order to see the parabola, we should really do a few more points than that. I'm going to do 7 here. That should be enough. You could probably get away with 5, but the more you do, the clearer it'll be. The clearer the parabola will be. So I chose some values here, and keep the x values small, and use some nice whole numbers like this. Um, so let's just plug them in and see what we get. So if I were to plug 0 in, I would get 0 squared plus 3. 0 squared is 0, and plus 3 is 3. So f of x would be 3 when x is 0. Plugging in 1, 1 squared plus 3. 1 squared is 1 plus 3, so that'd be 4. 2, plugging 2 squared plus 3. 2 squared is 4. And then plus 3 would be 7. And then 3 squared plus 3. 3 squared is 9. Plus 3 is 12. Okay, and then -1. So let's put -1. Negative. -1 squared plus 3. -1 squared, -1 times -1 is 1. Plus 3 is 4. -2 squared is 4. And then plus 3 would be 7. And -3 squared would be 9 plus 3, which is 12. And anytime you take a negative number and raise it to a power that's an even number, in this case 2, it'll become a positive number. Okay, so it's 12. Okay, so now we have a table of values, and we're going to plot this f of x on the y-axis. So just if I were to write these down more cleanly, 0, 1, 2. Actually, that's not going to fit. Forget that. Okay, so we're gonna this will be our x coordinates, and these will be our y coordinates. Okay, you can see that we get up to the number 12. So let's see how many lines we have on our y-axis. 1, 2, 3, 4, 5, 6, 7, 8. So that's not going to fit 12 if we say that each one of these represents one unit. So let's say we go by twos, and I'll just write that down. So this line will represent 2, 4, 6, 8, 10, 12, 14. Then we'll be able to fit. And then the x, let's keep that. Let's keep these 1, 2, 3. Just choose a scale that will fit your values. Okay, so let's plot these guys. So the point 0, 3, 0, x is 0, and then 3. 3's will be between 2 and 4, so put that right in between there. 1, 4, so x is 1, y is 4, so 2, 4, and then 2, 7, so x is 2, and then y is 7, so 7 is between 6 and 8, so we'll put that there. And then 3, 12, so 1, 2, 3, x is 3, and y is 12. And then we've got negative 1, 4, it's 4 there. Negative 2, 7, so 1, 2, negative 2, and 7 between 6 and 8. And then negative 3, 12, 1, 2, 3, and then 12. And then, so that's looking already pretty parabola-like. So let's just connect these guys. Something like, I don't know, start up here, connect down through. It's not going to be exactly perfect, but, okay, this should be a little bit more, have kind of a steeper curvature there, but that gives you the basic idea. The parabola should be a little bit more symmetrical like this. But yeah, just connect your points and make sure you've got a lowest point or a highest point if your parabola looks like that. But if you plug in 7 or 8 or 9 points, that parabola shape should become pretty clear, and then you can just draw your parabola. Actually, let me put arrows at the end. So it goes on forever in both directions. Yep. All right.